Hey everybody, and welcome to the channel. Today we're diving headfirst into the exciting world of chemistry to explore the top 10 most mind-blowing chemical reactions. These aren't your average vinegar and baking soda volcanoes, people. We're talking serious, how is that even possible level reactions? From erupting foam to color-changing liquids, glowing solutions, and even fire-breathing reactions, we're about to witness the magic of chemistry in action. So buckle up, put on your safety goggles, and get ready to be amazed. It's about to get explosively awesome in here. Alright folks, let's kick things off with a bang. Or should I say a foam-splosion. This is Elephant's Toothpaste, and it's every bit as wild as it sounds. We're combining hydrogen peroxide with potassium iodide. The potassium iodide acts as a catalyst, speeding up the reaction. As the hydrogen peroxide breaks down, it releases a ton of oxygen gas. To capture all that gas and create the iconic foamy fountain, we add a little dish soap to the mix. The soap traps the oxygen bubbles, creating a massive eruption of foam that just keeps on growing. This reaction happens super fast, generating a lot of heat in the process. It's exothermic. But seriously, look at this thing. It's like a giant foam monster erupting from a bottle. It's messy, it's chaotic, and it's a perfect example of how even simple chemical reactions can have spectacular results. Hold on to your earmuffs, folks, because this next reaction is called the barking dog, and it lives up to its name. Brace yourselves for a loud pop. We're using hydrogen peroxide, potassium iodide, and a little bit of soap. Instead of a foamy eruption, this reaction creates a rapid expansion of gas that produces a loud barking sound. The gas is trapped inside a long glass tube, and as it builds up, it forces its way out with a loud woof. The flame you see traveling down the tube is actually the ignition of some of the hydrogen peroxide. Get ready to be dazzled because we're about to dive into the world of chemiluminescence, where chemical reactions produce light. Forget glow sticks, this is the real deal. We're going to use a chemical called luminol, which releases energy in the form of light when it reacts with hydrogen peroxide. As the luminol molecule calms down and returns to its ground state, it releases the excess energy in the form of light, a beautiful blue glow. Chemiluminescence isn't just a cool party trick, it has real-world applications, particularly in forensic science. Investigators use luminol to detect bloodstains at crime scenes. So, the next time you see a crime show where they're spraying stuff to find blood, you'll know it's probably luminol in action. Hold on to your hats, folks, because things are about to get extremely hot in here. We're talking about the thermite reaction, and it's not for the faint of heart. This reaction is so exothermic that it can melt metal. We're talking temperatures over 2,500 degrees Celsius. By combining iron oxide with powdered aluminum, we create a chemical showdown of epic proportions. The aluminum steals oxygen from the iron oxide, releasing a massive amount of energy in the form of heat. The heat generated is so intense that it can melt the iron produced in the reaction, creating a shower of molten metal sparks. The thermite reaction has several practical applications, including welding and metal cutting. Now let's cool things down a bit with a reaction that's a little less explosive, but just as visually stunning. Prepare to be mesmerized because we're about to witness the mystical Pharaoh's Serpent. This reaction is like something out of an ancient Egyptian tomb. The star of this show is mercury 2-thiocyanate, a chemical compound that undergoes a dramatic transformation when heated. When we ignite mercury 2-thiocyanate, it decomposes, releasing gases like carbon dioxide, sulfur dioxide, and nitrogen gas. As the gases escape, they push the decomposing mercury 2-thiocyanate outward, creating a long snake-like structure. The resulting serpent is actually a porous solid made up of carbon nitride. The Pharaoh's Serpent is a prime example of a chemical reaction that produces a dramatic change in both the physical and chemical properties of the starting materials. However, it's important to reiterate that mercury 2-thiocyanate is a toxic substance and should be handled with extreme caution. Now let's move on to a reaction that's a little more explosive. Get ready for a dazzling display of pyrotechnics, because we're about to break down the chemistry behind fireworks. Fireworks are essentially carefully controlled explosions that use various chemical compounds to create their dazzling effects. The key ingredient in most fireworks is black powder, a mixture of potassium nitrate, charcoal, and sulfur. When ignited, black powder burns rapidly, producing a large volume of hot gas that creates the explosive force needed to propel the firework into the air. Different metal ions emit specific wavelengths of light when heated, a phenomenon known as atomic emission spectroscopy. By carefully selecting and combining these metal salts, firework designers can create a kaleidoscope of colors that illuminate the night sky. The next time you watch a fireworks display, take a moment to appreciate the chemistry behind these dazzling spectacles. Get ready to be amazed by the magic of the silver mirror reaction. This stunning demonstration transforms a clear solution into a reflective silver surface right before your very eyes. The secret behind this mesmerizing reaction is the Tollens reagent, a solution of silver nitrate and ammonia. When Tollens reagent is mixed with an aldehyde, the silver ions in the reagent are reduced, transforming into metallic silver atoms. This creates a smooth, reflective layer of silver, effectively turning the container into a mirror. The silver mirror reaction is not just a dazzling display of chemistry, it also has practical applications. For example, it's used in the production of mirrors, Christmas ornaments, and even thermoses. So the next time you gaze into a mirror, take a moment to appreciate the chemistry that makes it all possible. Fasten your seatbelts, folks, because we're about to witness the explosive power of hydrogen. This is not just any ordinary experiment, it's a thrilling demonstration that showcases the raw energy stored within the simplest element in the universe. This demonstration involves igniting a balloon filled with hydrogen gas. The setup is meticulously planned to ensure safety while providing a spectacular visual. Hydrogen is the lightest and most abundant element in the universe, but it's also highly flammable. Its properties make it a fascinating subject for scientific experiments and educational demonstrations. When mixed with oxygen in the air and ignited, hydrogen combusts rapidly, releasing a significant amount of energy in the form of heat and light. This reaction is a perfect example of how powerful chemical reactions can be. In this experiment, we'll be filling a balloon with pure hydrogen gas. The process requires precision and care to ensure the balloon is filled correctly and safely. Once the balloon is filled with hydrogen, we'll attach a small candle to a long stick and use it to ignite the balloon from a safe distance. This method ensures that the ignition process is controlled and minimizes any risk. When the flame reaches the hydrogen gas, it will ignite, causing a rapid combustion reaction with the oxygen in the air. This reaction is both quick and powerful, demonstrating the explosive potential of hydrogen. The result? A loud boom and a bright flash of light as the hydrogen reacts with oxygen to form water vapor. This dramatic effect is a clear indication of the energy released during the reaction. The hydrogen balloon explosion is a dramatic demonstration of the power of chemical reactions and the importance of handling flammable materials with care. It serves as a reminder of the incredible energy stored within chemical bonds and the need for respect and caution in scientific experiments. Prepare to be mesmerized by the captivating dance of Pharaoh fluid. This unique substance moves in ways that seem almost magical, creating a visual spectacle that is both intriguing and hypnotic. This otherworldly substance seems to defy gravity, forming intricate patterns and spiky structures when exposed to a magnetic field. The spikes and peaks appear as if they are alive, constantly shifting and changing. Pharaoh fluid is a colloidal suspension of nanoscale magnetic particles in a carrier fluid, typically oil or water. These tiny particles are so small that they remain suspended, creating a fluid that responds dramatically to magnetic fields. When we bring a magnet near Pharaoh fluid, the magnetic particles align themselves with the magnetic field lines, creating visually stunning patterns. These patterns are not just beautiful, but also reveal the invisible forces at play. The spikes and peaks you see are a result of the magnetic particles trying to get as close to the magnet as possible, while still maintaining their suspension in the carrier fluid. This delicate balance creates the mesmerizing shapes we observe. The shape and movement of the Pharaoh fluid can be manipulated by changing the strength and orientation of the magnetic field. This allows for endless possibilities in creating dynamic and ever-changing forms. Pharaoh fluid has a range of practical applications, including use in loudspeakers, hard drives, and even as a contrast agent in magnetic resonance imaging, MRI. Its unique properties make it invaluable in various fields of technology and medicine. But it's also simply fascinating to watch, offering a glimpse into the hidden world of magnetism and nanotechnology. The interplay of science and art in Pharaoh fluid's movement captivates both the mind and the senses. Get ready to witness the captivating growth of a chemical garden. This fascinating experiment is not just a visual treat, but also a wonderful way to understand some fundamental principles of chemistry. This mesmerizing experiment demonstrates the principles of solubility, precipitation, and osmosis to create delicate, plant-like structures that seem to sprout from nothing. It's like watching a miniature underwater forest come to life right before your eyes. To create our chemical garden, we'll start with a solution of sodium silicate, also known as water glass. This solution forms the base in which our garden will grow. Next, we'll add a variety of metal salt crystals, such as copper sulfate, cobalt chloride, and iron chloride, to the sodium silicate solution. Each type of crystal will contribute to the unique colors and shapes in our garden. As the metal salt crystals dissolve in the sodium silicate, they form colorful metal ions. These ions are the building blocks for the structures that will soon emerge. These ions then react with the silicate ions in the solution, forming insoluble metal silicates that precipitate out of solution as colorful solids. This reaction is the key to the garden's growth. The precipitated metal silicates grow upward, creating delicate plant-like structures that resemble trees, flowers, and coral reefs. It's a stunning transformation that showcases the beauty of chemical processes. The chemical garden is a captivating demonstration of the principles of chemical reactions, crystal growth, and diffusion. It's a perfect blend of science and art, making it a favorite among both scientists and artists alike. Thanks for joining me on this explosive journey through the world of chemistry. I hope you were just as amazed by these mind-blowing reactions as I was. If you enjoyed this video and want to see more awesome science content, be sure to give it a thumbs up and subscribe to the channel for more exciting experiments and discoveries. Until next time, stay curious.